Давайте тихонько начинать. Привет, hello, добрый день.
I suggest we start already. Hello, everyone. My name is Maxim. We optimize testing in UGIM. Sometimes it says that I work at EPAM and I've never worked at EPAM, and it would be strange to work in EPAM and speak about the product company testing. Has anybody heard about Agri Game? Raise your hands. Have you heard about Patch Ignite? More people. Good. Greek game, okay. What is Apache Ignite? Apache Ignite is an open source solution for the distributed database, which can also be a cache, distributed, distributable, and scalable. And Grid Gain is the solution based on AI for enterprise projects, whereas Apache Ignite is all sorts of messaging, tracing, and storage of data, and computer-grade machine learning, SQL synthesis. We can apply it in the Internet of Things. You can apply it in mobile applications, banking applications, whenever you need to scalability, speed, or both. GridGain puts on all sorts of add-ons like monitoring, data analysis, replication between data centers, advanced security. Also, we have backupping for the scheduling and restoration from backups. This is what we're testing here, but I would like to speak about here what kind of problems we face as a product company and how different it is from, say, an outsourcer. The principal problems that we are facing is the testing of big number of interfaces, big number of versions in production, and all sorts of different configurations. These are the main things, but we can add some smaller, minor problems, like the problems that the customer has hardware, and hardware might also have problems, and that we have different editions, communities, enterprise, ultimate. They can also be different, and artifacts themselves could also be quite big. And another challenge that any company with automation faces, not only product company, is the testing structure, how to build or structurize tests better. Let's speak about it one at a time. First is the numerous interfaces. We're a product which fits different tasks. For different tasks, different tools fit better, different programming languages. So that's why we have interfaces for all popular languages: Java, .NET, C++, Python, GS, and as long as we are a database, we have ODBC and JDBC now. And REST is also popular. We have REST API also. We also like consoles. That's why we have CLI. And we're in 21st century, we don't like consoles. That's why we have web. And all of these things need to be tested. How? Well, first iteration, quite obvious, is that for all of these IPs, they have their own tools. Let's use them. Why reinvent the wheel when they're already implemented, tested, documented, and they're broken down in different articles and fora? It's good, but in our case, first of all, each instrument must be known quite at a high level of detail. When you have, say, 6 programming languages, and for all of them you need instruments that you need to have detailed information about, it's hard to find such an engineer. Even if they know how to do that, they will be hiding from you, and they are quite rare and expensive engineers. And we have stranger code, and if we want to change or improve something, we cannot simply take and do this. But there's a caveat here. If it is an open source, you can do it upon request. To contribute into open source, actually, has anybody done that? 1, 2? How many people? 4 people? Great. All of you are advised. This is very good to do that. I won't tell you why, but you can open source it. But in any case, you will have to put in the request, wait for its review, and wait for you to clean up all sorts of complaints and clean up a number of tests. It might be proprietary, but the developer might have a public board where you can vote for different features or suggest your own features. Then features might be developed, but it's never known when it is going to be developed. In any way, it is going to be too long, and we don't want to wait. That is why we decided whenever possible, we decided to rewrite it for Python. The product itself is written on Java. Why tests are written on Python? First of all, because it's a very popular language. The library is huge, and the library has features for all tasks, and we have same advantages on the previous slide. For all interfaces, simply take a code. It's already written, tested. It's rarely well documented. At least it's described in articles and fora. And as a result, we have all the advantages, like the advantage in the previous slide. And Python is also friendly. Very low entry threshold. When I came to Greek game, I knew Java. I didn't know Python very well, but in the first week I already started to write tests. To write tests for Kaviko, you don't need to know much. Thirdly, as soon as that was in another company's code, we can control the real behavior. If we wrote it in Java, we would have used code on the C. We would have gone down one level down, cut corners, but still there would be bugs with the client. When you connect from outside, it will be the same as the client would have connected, and so it's a real behavior, which is good. Also, Python has another thing that at one moment in time only one flow can work. You can have different names, but this is also an advantage. We don't have to compete with other tests and things, but performance is not as much as we would have decided. And it's okay for us, and this problem has been solved by us. Next problem that we have is the version in production. Which one of you works in open source, sorry? Raise your hands high. Not many. How many versions do you usually test when working in outsource? Simultaneously. One. Any other answers? Okay, one or two. Okay. One which you've already given to customers, and another which you're about to give the customer. But we have more than 100 versions in production. Why so? Because clients come to us at different moments in time, and when they come, they install the most recent version then. To install this product is not that easy, but anyway, as soon as you install it, connect it, the results are to your liking, good, then the customer is happy, and they simply renew your contract. They're not going to constantly jump to other versions on release. They're not interested in features that you prepare for other clients. That's why we have to maintain. The new client comes, uses a new version, we have to support it. Also, we do a number of parallel releases for different customers, and more than 100 versions in production. All of them need to be tested. And the question is how? Initially, for each release, we appoint a separate release engineer who worked in a separate workflow. So basically, I'm not concerned if my release doesn't work on another version. It works with me, and it's good for me. But you see, there is a lot of room for disadvantages. Can you name some of them? I cannot hear the comments from the floor, unfortunately. That's all right, but it's impossible to keep all the context in the head. Okay, backing up, yes. Thank you. What? No, we're only talking about the releases which are in production now. We are not doing on a parallel the history of releases. But we are testing everything. But as to the actual release management, you have managed almost everything. It's hard to compare the coverage, for instance, because someone can test the same thing in 7 different tests, Others can put it into a single suite. Others called it differently. Or somebody tested it with smoke, others did it in more detail. So the human factor cannot automate it. We cannot automate human factor. Secondly, if the changes are not in the test code but in this general area, then it has to be drawn into each ramification, which is quite painful. Another thing, can be another situation when some feature never inspired any interest, but it was covered by basic smoke tests, and then manager with burning eyes comes to you and says that there is a huge interest to this feature, its top priority needs to be well covered. Then you'll have to write new tests for each ramification of each branch separately, which basically there are many pull requests. They're similar, and if you read them inattentively, then you can miss some bugs and ruin the code, which is quite deplorable. Unfortunately, aside from the code, it's bad that we put the release cycle on the availability of the engineers. If I want to go on vacation for specific days, I want to make sure that I'm not going to do any release on those dates. If other way around, I'm doing some release, I don't want to go on vacation. What happens if I get ill or if I'm abducted by aliens, then the release needs to be postponed, and we cannot afford to do that. That is why we have done this in the framework way. It means that the framework can change the behavior of tests depending on the version it's using. Here you get another advantage when you don't need to compare the coverage. It's full everywhere, with the exception of those tests which appeared starting from a certain version. And those tests which disappeared starting from a certain version, we remove the functions here and we move to another story. But actually the tests exist everywhere. It's much better that the changes are pinpoint and minimal. We change only what has changed. And to connect or switch between different versions is easy as pie. You don't need to keep a huge context in the head because the whole context is in the repository. Here you can have a considerable disadvantage that you need time for that. You need to put everything together, think of the whole idea, put all the tests together, see that you haven't lost anything. This is time, which doesn't bring new test cases to you. And you need to somehow justify it to your manager. And a famous story about here from a party that once upon a time there was a lumberjack who was quite responsible and diligent. He every day went to the forest and cut down trees. With time, because of his diligence, the axe became blunt and he could fell only one tree. He was told, you know, guy, go and hone your axe, spend say 2 hours or half a day, then you'll be able to fell 5-6 days per day. I don't have time for that shit, he said. I need to fell trees. So don't be such a stupid lumberjack. Be like Dmitry Sitrakan said, think about it, because the planning hours can save a lot of weeks of coding. But these are all stories. Let's speak now, or rather look at the code. Here you can see the test script of GridGain company, Python language that we write tests with. Here you see the Llamo test. And there are 3 methods. There might be more of them, of course, but these are the 2 strip test cases. And here is where the tests are executed. What is Llamo test? In fact, this is the class that we wrote to ensure YAML file. You know what YAML files are all about. This is like tree structure, similar to JSON, more laconic. Everybody hates them, but everybody uses them. In Llamo tests, we store the values which can jump from one version to another. Llamo test is iterated there, and then we put it together, which need to be run, and from YAML tests we call up all these test cases with the necessary context. How do we want to merge the versions themselves? At the bottom we have YAML file with the oldest version, with the test that we're going to move through. Something changes in this feature and we have created a new YAML. Then 877 changes again, and something changes in these versions, and only for these versions we create YAML files. Then the version 876 comes in, we put on the changes here, we merge up the updates, and 877 is older, so these changes are not all about us. That's how we move on, and these transitions, there might be changes in tests, skipping of tests, adding new ones, and deletion of the old ones, and defaults which were written for each case, and the first set of cases here. And the YAML files themselves look like this. For version 854, the first feature that we have many methods here. In 874 and 75 we have only one method each. Let's look at the restart. For instance, that was the only thing that changed here in our context. The original feature appeared there and we had to start it with the XML server. This is the configuration which is used to raise it up, and the cluster had to be activated, and test case idea was to track it down. 874 version, the functionality has been revised considerably, and that's why we need to start from the configure XML. We don't need to activate in the cluster anymore, so it's quite minimalistic. In the version 785 we found a bug, and doesn't make sense to launch it in Jira, and it's not going to waste our time. We just the test because the bug was 1.4.5. Very minimalistic, and as you can see, the test code is here in these methods. It's not related to versions in any way. Everything is separate. It's quite convenient. We have one here, that's why moving on. And the configuration is the biggest problem faced by NMR product, because we don't know how we're going to be used. Unlike the outsource, we don't know which hardware or operating system is going to be used. We don't know the size of the cluster. At the same time, we have to test big clusters and small ones, but we want to get the results in time, so it doesn't make sense for us to deploy it in a large cluster and say that we are working on 4,000, which means that we can work on any typology as well. Hipsters want containers and they want to deploy differently. All of this is taken under advisement. Now about the containers. Tests do not contain any information about that. Whatever is related to deployment is automated, and it is kept in a separate place, and it's enough for me to put it in a Docker. And again, depending on that, I'm going to the required arm or branch, and I will separate it there. So I run the same tests in any random deployment that I want. The next thing is the differences in typology. It is symbolizes the typology. Here we have cluster. The main idea is that, again, in YAML file configuration, or whenever I'm starting it, I put in the variable, how many details I have, what APs, and what nodes in each host I want, what loads, and I run the same tests in all clusters. The test doesn't even know what's under its feet. There's a huge cluster distributed throughout many continents, or a small one in one node on your local machine. But there will be no current solution and the first iteration, because with the first iteration we have good current solution. Now let's move to smaller problems then. Maybe our software in IKEA, but we cannot be sure that, well, what kind of hardware the client uses. We have to be prepared for it to crash, and it crashes sometimes. And when the cluster is distributed, the more machines we have under your feet, the higher is the probability that some disks will burn down. Yesterday was an interesting presentation about that, and we simply take and automate it. Let's look at it now. Emulate packet loss. It's clear from the name that we're losing the package, or there's a breakdown in the network. You don't need to read all these things. You simply emulate the network breakdown. We launch the text, run the text, and we start getting data, replications, and here all of a sudden some part of the cluster will lose the net. And then you re-switch it, it works okay, and you see that all the data have reached it, and it has been homogenized. Then CO start. Here we emulate the pressure on the disk. Instead of we see that the disk starts slowing down, and the application starts to react to it very well. And if you remove the load, then it starts working well. We know how to put more pressure on the disk. We know how to break down the net. We know how to simulate the loss of writes to the filing system, to writing and reading, then normalize the situation and see that the cluster has restored itself. Without normalization, see that the data have not been lost. We automate it, and it's great. The next problem are artifacts.
Since we have interfaces for all situations and pressures for situations, artifacts are quite fat, over 500 megabytes. At the same time, to start test, you need to transfer to wire network to many points and deploy them. Say our local network is fast, but you won't start deploying it multiple times. It's fraught with problems. Not all the modules are needed in each test. So we simply wrote our repack program that repacks the archives, leaving only what is needed in a particular set of tests. Archives weighs less than 100 megabytes, so the deployment growth is 5 times more, which is fine with. Another difference is between editions. Some features have started from community, some are only available in the Ultimate. Consequently, when I launch a test of the enterprise and test it. In the community, I need to say a label. Unfortunately, this is only supported in the enterprise and Ultimate. Please pay. If I launched in another edition, I need to test the whole business logic. The solutions is here to similar to version here. Depending on the edition, the framework will use this particular approach. Next problem is the test structure. I faced it when preparing the presentation. Initially, it wasn't there. It was there, I just didn't know about it. Part of the product can become a product of its own, what it means. For example, we have a single cycle. Then we decided that it would be a special product, a separate program with its own release cycle. So, well, here was 855, 877, 779. The new client started from scratch 1.1.0, and here they started with the year, month, and day. If all the tests were put in a pile or organized based on scripts, as I saw it in my previous workplace, then we would have these tests to write from scratch. Would cut in what is needed for clients from here, but we didn't have to do it. So if the test is a test console, it was put from the beginning. What we had to change is on the right, test code sample on the right. No matter what it does, on the left you can see example of a configuration. You could send this YAML. It was a grid game version. it was used somehow on the right. We had to add a separate special line to the console version, then enter the module and find the spots where the web console version is needed. Simply replace it, that's it. So you were not able to do Control plus Shift plus R. It took me less than an hour, and it works like this, but we're safe because it was thought through at the initial stage. So it worked out fine. On a whole, the grid gain uses unified framework written in Python with the supportable interfaces. The framework changes the test behavior depending on the test condition. The framework deploys itself. We never had a DevOps. We don't need a DevOps. It's all done automatically by several configuration lines without a code. Artifacts are repacked to decrease the deployment time, and hardware issues are also tested. Thank you for your attention. Your questions, please. Thank you. You said that eventually you put everything in the master file, so no release branches. Why not make tests in the master? What support versions of tests? I'm sorry, I didn't think I understand the question. The master is relevant. It's also relevant by my parallel versions because I support everything that was released in the last 2+ years. Somebody is still using the version 8.4 something. Part of the clients are using 8.5, and other clients using 8.7, plus new releases. If client doesn't work fine with one of the clients, I check this version. So I had to be ready to be able to launch everything in the last 2 years. Did I answer your question? I can discuss it later with you after the presentation. Hi, my name is Pavel. Thanks for the presentation. You said that you parallelize the test using several nodes. But why not simply fork several processes in one host and execute this test? My second question is, you have a test pool. How do you distribute? Which test will be used in which node? You need a special manager. Do you have it? How does it happen? Hi, Pavel. Let's describe what you call a node. You said that different hosts you launch test runs in order to get them launched in parallel. Maybe I didn't got it right. Yes, we have several testers with different tasks, and there is a CI with a lot of agents. You launch a suite, another tester is launching a different suite. You test in different things. Oh, I understand. So roughly speaking, inside of suite there's a consecutive run. If 2 testers launch it simultaneously, it will be parallel testing. If you want to execute 2 in parallel, do you have this option? Within the one machine? No, we don't have this option. We don't need it. Thank you for your presentation. The following question. How do you keep your test documentation? Do you use BDD approach? We don't use a BDD approach, unfortunately, because we still a little bit of a startup, feature first approach. So we cover the test. We don't even have managers who would specify and formalize new approaches. We just agree that this should work like this. When it's done, we test how it's done, but BDD is something that is still in the future. And documentation. In standard understanding, in regular understanding, we don't have this because it's a middleware. I think Jira is enough. You just show what you launch with what parameters, and our documentation goes down to Jira. So how a rookie, a novice, could join the testing process? So a new tester wants to join the team. How do you help them, adapt them? It's very painful, you know, it's very painful. But there's no other way around. But we have a person who writes in Python, but has a good background in Java, at least. Thank you for the presentation. My question is similar to the previous one. How do you review testers? Testers review testers, or you have a mentor from developers? Thanks. No, developers don't want to learn Python. They do it for their own purposes, but not in fault. But we do review each other. It's done for sure. Thank you for the presentation. I would like to know, you have 100 plus versions using prod. How many automators do you need to cover and successfully support all this version? You would not believe me, but we only have 7 testers. How do you, in this case, have a new person adapt into your system? It's hard for them to understand the whole chain in all the features in all versions. It was actually easily tracked. He simply opens the folder and sees here only what minor difference between versions. If iron mesh is here, iron mesh is in other versions as well. The message here is you shouldn't run away from the context. It's all in the code. And another small question: between testers, is there exchange of experience, or somebody discovers a particular field, say part of the app, and only works on this, and writes tests on this? No, we have specifications like load testing, functional testing, but in terms of fields or areas, we almost don't have it. So any auto tester can write it. Well, the only person special here is me, because I found myself here, so I don't need to know details about this. But the guys who are here, they don't need to go here. They know what's happening there, but they don't need to know the details if I can answer the questions promptly. Thanks. Thank you for the presentation. My name is Tim. The question is following. If you support 100 plus versions, they need to be compatible, legacy code and all this. How do you cope with tons of legacy code? How do you sort it out? How do you test it? Do you need to make the new version compatible with the old versions? You mean the compatibility of all the versions? Say a client wants to migrate from version 4 to number 7. Yeah, we have a feature called rolling upgrade, our own. Here, it's called rolling upgrade. You simply input a topology in the cluster. You wait for data to be back up in new nodes and turn off the old versions. So it's done on the fly. The code doesn't have problems of the. You mean the test code? I mean the production code. The clusters with the new topology would not let in new nodes. No, we're digressing. If you let's discuss it later, because somebody may have a more relevant question. Thank you. Thanks for the presentation. Let's go back to the slide with multiple versions. Looks like the new framework version doesn't have old functionality regress. There's the new version of framework. A little example of what changed, but then is the regression of new functionality. Here you launch only nodes on this version. You test it. If you test and roll upgrade, you only test in that during the update everything flows over. And testing the fact that you have a mixed cluster launching and it exists, you can achieve it. There are means for it. You can start nodes of different versions, but it does exist. Thank you. But we're not concentrating on this because it's not the same. We have some time. Thank you for report. It was a nice report. Can you go back to the 11th slide? I maybe misunderstood when you wrote that. What you wrote on this slide, let's say from master. No, we didn't branch out to a new release. It's all down in the master. As a tag, you mean? As a tag. No, it's a test code. It has its own evolution. In this case, production also has a master file. I mean the development file. The product has its own evolution. There are some branches of sub-releases. Turns out the tests in the master, they are matched with the master. No, it's Java, it's Python. I don't really understand the question. If you make a build of product master and launch tests from the master of your own project, they need to be run. You will not be able to launch it. You need to learn which test you will be running. So the releases are fixed, they are not moving. I don't understand. I mean the patch version will be changing. Patch version is also produced by us. But they call the separate versions. Thank you. Just a quick question. If, for example, you get a bug from a customer from old version, it is very special. Do you drag it through all your 100 plus versions that are up and down? If you mean the bug from an old version, yes, I understood that. We check it. It could be fixed. Could have been fixed at some version. We check it at the older versions because some features used by particular customers. We check it everywhere where it can be detected. A customer can reject the fix if they don't need it. Thank you very much. I have 2 t-shirts. Can I take a picture with you? It's fashionable and my diameter will love it. I cannot fit everyone. Okay, I have 2 pictures. Best questions. Who raised hands who asked questions? For beautiful eyes. Thank you. Please don't forget to vote.